In part 1 of this lesson, we'll look at a couple of topics from number theory. To start with, number theory is the study of the integers and the properties that they possess. It is one of the oldest branches of mathematics, dating back to about 1800 BC, and in this section, we'll focus on just the positive integers, so not the negative integers as well. So really, we're just looking at numbers like 1, 2, 3, 4, and so on. So I'll put a ... to say that these go on forever. We want to consider these as a set of numbers, and the notation for this is to put curly brackets on either side of all of these numbers, and we call this a set or a collection of numbers. In fact, the positive integers, which are denoted by this capital N here, are also called the natural numbers. So these words are interchangeable. Now, what are some of these properties that were first looked at within the natural numbers or the positive integers? So here's one. If we look at the number, let's say 6, one observation that you can make is, well, 6 is 2 plus 2 plus 2. You can use numbers before it to count up to it. And you can do the same thing with, let's say, 3 plus 3. So you can actually split apart the number 6 as a product of 2 and 3. Does this work for every single number in the list, like 5? Well, if you try to do that for 5, if you split it apart with 2, it doesn't quite work. So you can observe that, well, some numbers can be broken apart, and then other numbers cannot. And this will lead us to our first definition of divisibility. Let A and B represent any two positive integers. We say that B is divisible by A, or that A divides B if there is a remainder of 0 when A is divided into B. Here's the notation that we'll use for A divides B. We'll write A with a vertical line and then B. And this means A divides B, meaning when you divide A into B, there's a remainder of 0. If A does not divide B, we can write this. So it's the same idea, but we put a line through it to say A does not divide B. So A does not divide B. So with this example up here, we could write something like, well, 2 divides 6. The reason that this is true is if you do long division, 2 goes into 6 3 times, and yeah, you have a remainder of 0 left over. Likewise, 3 also divides 6, or you could say 6 is divisible by 3. Again, by long division, 3 goes into 6 twice, again with a remainder of 0. But 2 does not divide 5, for example. If you take 2 and divide it into 5, well, the closest you can get is 4, and this leaves you with a remainder of 1. So here the remainders were 0, so we could say 2 and 3 both divide 6. Over here, the remainder was not 0, so 2 does not divide 5. So in the rest of this lesson, we will look at rules that tell us when one number divides into another or not. In example 1, let's use long division and also a calculator to decide whether 2 divides into 35, 100, and 2,030,000,4,555,006. I'll start with 35. So does 2 divide 35? Now, I'm guessing you might already know the answer to this, but just to explore this question, if you use long division, let's see, does 2 go into 35? Well, it goes into 3 once. You have 15 left over. You can multiply by 17, which takes you to 14, but here the remainder is not 0, it's 1. And so the answer to this question is 2 does not divide 35. If you use a calculator, if you type in 35 divided by 2, you get 17.5. And the fact that there is a decimal that's not 0 at the end means 2 did not evenly go into 35. So in a lot of ways, it's pretty simple to figure out the answer to this question. You could do long division, or you could simply divide in a calculator. Let's try this with 2 going into 100. Again, you might already know the answer to this. But if you use long division, does 2 go into 100? And the answer is yeah. it goes into 10 5 times. There is 0 left over, and 2 goes into 0 0 times, and you do have a remainder of 0. If you were to do this in a calculator, if you do 100 divided by 2, no surprise, you get 50. It doesn't even give you a decimal, so the decimal is 0. Here, a remainder of 0 or no decimal in a calculator means this is true. 2 does, in fact, divide 100. Okay, last one. Does 2 go into this number? I'm not actually going to do long division or use my calculator for this. Long division would actually be a really long, tedious process. I'm sure we could do it, but it would be a bunch of writing. And if you were to type this into a calculator, like some calculators don't even have this many place values. It might not even be possible. There's a much simpler way to look at these numbers to determine if 2 divides it or not. And you can simply look at the last number, in this case the 5, the 0, and this 6. Turns out, if the last number is even, then 2 will go into it. And the reason for this is, if you count by 2s, you will always end in an even number. So really, you don't need to do any of this work if you know this rule. You can look at 35 and say, oh, it ends in a 5. 2 does not divide 35. There's no other work to do. 100, well, that ends in a 0, and 0 is even, so this will work. But you don't actually have to do all of this work to prove that. The same thing goes for this. We can simply say 2 divides into 2,030,000,000,000, 4,555,006. And the reason for this is it ends in an even number, and specifically that number is 6. No other work is necessary. So this saves a lot of time. Now there are other rules for not just 2, but there's ones for 3, 4, 5, and so on. Before moving on to these rules, let's go back to 35 and 100 really quick. So I just want to throw this out there. Does 5 divide into 35? Is this true? And this is in fact true. And the reason is really similar for that of 2. If you count by 5s, every number ends in a 5 or a 0. So again, here you can just look at the last digit and say, oh, it's 5. Therefore, 5 must go into it. You could say the same thing about 100. Does 5 divide into 100? And again, this is also true. And the reason is the number ends in either a 5 or a 0. There's no other work that you need to prove this statement. Another one that's similar to this is 10. Does 10 divide into 35? And the answer here is no. This is not true. In fact, you can put a line through this. And the reason is the only way 10 can divide into a number is if the number ends in 0. And here this ends in 5. Does 10 divide into 100? Yes. Yes, this is in fact true. And the reason is the number ends in 0. On the next slide, I'm going to list several divisibility rules for 2, for 5, and 10, and for several other numbers as well. So as discussed in the previous example, we have simple divisibility rules for 2, for 5, and for 10, and they're very logical. If you count by 2s, the number must always end in an even number, 0, 2, 4, 6, or 8. If you count by 5s, the number must end in 0 or 5. And if you count by 10, the number must end in a 0. So if you want to know if 2, 5, or 10 divide a given number, you just have to check these facts, and it makes it very quick. So these are pretty easy to see why they're true. Now, there are also rules for 3, 4, 6, 8, 9, and 12, and I'd like to discuss those next. The two that are most similar to the 3 rules that we have listed here are for if 4 divides into a number or if 8 divides into a number. Let's look at this one first. A number is divisible by 4 if the last 2 digits is a number divisible by 4. So an example for this would be 4 divides 50,216. Now, Why is this true? The reason that I know this is true is the last two digits form a number, and 4 divides that number. So if you want to know if 4 divides this value, you don't actually have to check the whole number itself. You can look at the last two digits and say, is this a number that 4 goes into? If the answer is yes, then 4 must divide the entire thing. If the answer is no, then 4 does not divide it. The next rule on this list that is similar to this one is the rule for if a number is divisible by 8. And the rule is a number is divisible by 8 if the last 3 digits is a number divisible by 8. So an example for this would be something like 8 divides 99,888. Now, why is this true? The reason is, if you look at the last 3 digits, I know that 8 must divide 888. And if that's true, well, then it divides the entire number as well. So these are shortcuts. You could have a very long number. For 4, you just have to look at the last 2 digits. For 8, the last 3. The next two I'd like to look at are rules for 3 and 9 because those are similar as well. How can you determine if a number is divisible by 3? The rule is if the sum of the digits is divisible by 3. So an example for this would be 3 divides 147. The reason I know that this is true is if you take 1 and you add 4 and you add 7, that is, if you add the digits in this number, the result is 12. Well, 3 divides that. It divides 12. If 3 divides the sum of the digits, then it must divide the number as well. The rule for 9 is similar because it's basically the same thing, except we'll say the sum of the digits is divisible by 9. So a number is divisible by 9 if the sum of the digits is divisible by 9. So an example of this would be 9 divides, let's say, 57,600,000. And the reason is if you add the non-zero digits, that's going to be 5 plus 7 plus 6. That is 18. And 9 divides 18. And since it divides the sum of the digits, it must divide the entire number itself. The last two rules are for 6 and for 12, and these are similar to each other. So when is a number divisible by 6? It turns out that if 2 divides a number and 3 divides a number, then 6 must divide that number too, essentially because the product of these two numbers is in fact 6. So I'll say this happens if 2 and 3 divide the number. The rule for 12 is similar. I bet you could even guess it. When is a number divisible by 12? That happens if both 3 and 4 divide the number, because the product of these two is 12. So I'll say this happens if 3 and 4 divide the number. So let's apply these rules in a couple of examples, and we'll do that in the next slide. In example 2, let's determine if 360 and 2022 are divisible by these numbers, and we'll use the rules from the previous slide. Let's start with 360. By the way, 360 is the number of degrees in a full rotation. If you've ever wondered why this is the case, maybe we'll get some insight after we've completed this problem. So, first, does 2 divide into 360? And the answer is yes. We can write this down. 2 divides 360. And the reason for this is the number ends in 0, and 0 is even. So we can say 2 divides 360 because it ends in 0, and 0 is an even number. Now, what about 3? Does 3 divide 360? Well, if we sum these digits, if that number is also divisible by 3, then the answer is yes. So it turns out that 3 does in fact divide 360. And the reason for this is, if you take 3 plus 6, and I guess also plus 0, you get 9. And 3 divides 9. Since it divides the sum of the digits, it divides the number itself. All right, next. Does 4 divide 360? Is this a true statement? All we need to do is consider the last 2 digits as a single number. Is 60 divisible by 4? This is also true. We can check. Does 4 divide 60? Well, it goes into 6 once, and then into 25 times with a remainder of 0. Since 4 divides 60, the last 2 digits, it also divides 360. For our next rule, I know that 5 divides 360, and the reason for this is this ends in 0. And as long as the number ends in a 0 or a 5, then 5 must divide it. So again, we can say this is because the number ends in 0. Now, what about 6? Does 6 divide 360? Is this a true statement? And the answer is yeah. The reason for it is, well, up here we showed that 2 divides it and 3 divides it. If both 2 and 3 divide the number, then the product 6 has to divide it too. So this is true because both 2 divide 360, and so does 3. Okay, moving on to 8. Unfortunately, the rule that we have won't be too helpful here. It does turn out that 8 divides 360, but the rule says this is true if 8 divides the last 3 digits. Well, this number only has 3 digits, so we're stuck. We actually have to take 8 and divide it into 360 and see if we get a remainder of 0. Well, 8 goes into 360 4 times because we get 32. And then with the 40 that remains, 8 goes into 45 times, and we do get a remainder of 0. So this is true. The rule we have doesn't help us, but it is true. All right, what about 9? Does 9 divide 360? Now, we already know the sum of the digits is 9, and 9 divides 9, so therefore this is true. And the reason is 9 divides the sum of the digits, which is also 9. Furthermore, I know that 10 divides 360, and the reason for that is this ends in 0. So I can say that this ends in 0, and therefore 10 divides 360. And then lastly, 12. Does 12 divide 360? And the answer is also yes. And the reason is 3 divides 360, and so does 4. In fact, every number on this list divides 360. This is the reason 360 was chosen for the number of degrees in a full rotation. This number goes back a long time, way before the time of calculators. So you can divide a full rotation in a lot of different ways, and you never get a decimal. So it makes the arithmetic really nice. So this is a good reason for choosing 360 as the number of degrees in a full rotation. Now let's try this again for 2022, which you could consider as a year, the year 2022. Which of these numbers divide this one? Same logic. I know that 2 divides 2022, and the reason for this is because of this 2 here. The number ends in a 0. Does 3 divide 2022? This is also true. And the reason is if you add the non-zero digits, you get 6, and 3 divides 6. So that's a true statement. Now, does 4 divide 2022? And the answer is no. Here, if you look at the last 2 digits, which is 22, 4 does not divide 22. And that's all you do need to check. You could actually do the division out if you'd like to. 4 goes into 22 5 times, and you have a remainder of 2 left over. So it doesn't work out. Therefore, 4 does not go into this number. By the way, this means that the year 2022 is not a leap year. If 4 does not divide the year, then that year cannot be a leap year. Now, moving on to 5, let's see. I know 5 does not divide 2022, and the reason is, okay, well, this ends in a 2. It should have ended in a 0 or a 5, and it did not. Okay, moving on to 6. I know that 6 does, in fact, divide 2022, and the reason for that is we know that both 2 and 3 divide 2022. All right, so next, I know that 8 does not divide 2022. And the reason for this is we only have to consider the last 3 digits as a single number. And in fact, that single number is 22. And 8 definitely does not divide into 22. It goes in twice because you get 16. And then you're left with a remainder of 6, which is not 0. So because 8 does not divide the last 3 digits, which is really a 2-digit number, 8 doesn't divide the whole thing overall. Next, does 9 divide the year 2022? And the answer is no. We already considered the sum of the digits is 6. And I'll just state that, well, 9 does not divide 6. And since it doesn't divide 6, it can't divide the year 2022 either. So 10 also doesn't divide 2022. Notice that the last digit had to be a 0, and it's a 2, and that is not 0. So maybe up here, just for added emphasis, I could say the 2 was not a 0 or a 5. And we're at the last one here, 12. I know 12 does not divide 2022, and the reason for this is for 12 to work, both 3 and 4 have to divide it, but 4 does not. So 12 doesn't divide 2022 because 4 did not divide 2022. In our last example, example 3, I again want to see if some number is divisible by any of these. The difference here is this is a very large number. I would not want to use long division, and this might not even be possible within a given calculator. But all of our rules still apply. So let's start with 2. Does 2 divide this thing? And by the way, this is millions. This place value refers to billions, trillions, quadrillions, and quintillions. So you could read this number as 9 quintillion, 200 quadrillion, 808. So first, does 2 divide this number? And for shorthand, I'll just put 2 with a question mark after it. Does 2 divide this value? And the answer is yes. And that's because this number ends in 8, and 8 is even. No other work to show. Now, what about 3? Does 3 divide this number? We can check by adding the digits, or really just adding the non-zero digits. So that is 9 plus 2 plus 8 plus 8. That's 11 plus 16, which is 27. And, well, 3 divides 27, which is the sum of the digits. So the answer here is also yes. Okay, what about 4? Does 4 divide this number? We only have to see if 4 divides the last 2 digits and consider that as a single number. Well, the last 2 digits are 0 and 8, which, I mean, really we're saying, does 4 divide 8? And the answer here is yes. Therefore, 4 divides the number overall. I know the answer for 5 is, well, no. And that's because the number does not end in 0 or 5. So again, this ends in 8, and 8 is not 0, and it's not 5. For 6, the answer is yes. Again, because 2 and 3 divide it. And if they both divide it, then 6 has to divide it too. Now, what about 8? Does 8 divide it? Well, we only have to look at the last 3 digits. Does 8 divide 808? And the answer is yes. In fact, it goes in 101 times, and therefore the answer is yes. What about 9? Does 9 divide this number? Well, we already saw that the sum of the digits was 27, and in fact, 9 divides 27. It goes in 3 times. Since 9 divides 27, it also divides the number. And then we have 10. The answer here, of course, is no. That is because it ends in 8, and 8 is not equal to 0, so it does not work. The last thing to consider would be 12. Does 12 divide this number? And the answer is yes. And the reason is, well, 3 and 4 divide the number. All right, so that is it for this lesson.